In this video, we'll solve questions involving the applications of trig functions. We will only be looking at sine and cos functions in this video. Now let's get to the first question. Here it is. Question 1. It is suggested that the height ht, in bracket t, so it means the function, in meters of the tide above mean sea level during a particular day at sea break is given approximately by the rule h equals 5 sine pi over 6 times t, in brackets, where t is the number of hours after midnight. Now there are multiple parts to this question. Part A, it says draw the graph of y is h bracket t for 0 t to 24. Okay, let's draw the graph of. Alright, let's draw it. Now we need a few things to draw a graph. We need to look at this midline. Now there is no midline, so that's a translation. Vertical translation, there is none. Now look at the amplitude. The amplitude is the number at the front. It's multiplied to the function. So it's 5. Okay, I'm assuming you know all these things. So if you don't know these, go back and study these before and then come back. So now we look at the period. Period is 2 pi over 6. So that's 12. So there's 2 periods in this graph. So let's draw it. Some two x-axis, y, and that will be 5. That will be negative 5. Draw a line across. And that's 24. That will be 12. So there will be 2 cycles. Midline, midline. So it will touch somewhere around here, 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 and here. So let's draw it. The graph will look somewhat like this. Okay. Because it's a sine graph, it starts at the origin. Then it does 1 full cycle by the time it reaches x equals 12. And it does 2 cycles at x equals 24. Okay, that's part A done. Let's do part B. When was the high tide? Okay, now it's asking us to find when was the high tide. So we look at the maximum of the sine graph. Now obviously the maximum is 5 because that's the amplitude. Okay. So we substitute h, where you do h5. So it's saying 5 equals 5 sine pi over 6t. That's 1 equals sine pi over 6t. And we know that sine pi over 2 is equal to 1. Right? And we know that the domain is 0 t equals 4 pi, because that's 2 periods, 2 cycles, that's 4 pi now. So sine pi over 2, so pi over 2 can be our solution, but pi over 2 plus 2 pi, so 5 pi over 2 is our other solution, because that is in the second cycle and that is in the first cycle. So this is pi over 2, and this is 5 pi over 2. Now we're saying that pi over 6t is equals pi over 2, 5 pi over 2. So t is equal to 6 over 2 and 30 over 2. It's 3, 15. That's saying that the high tide was at 3 a.m. and 3 p.m. because 15 is 3 p.m. Now let's move on to part C. Part C states, what was the height of the high tide? Well, so it's 5 meters, but we need to say that's 5 meters above the mean height. So the mean height is our midline, and in this case our midline is y equals 0. So we just say that it's 5 meters above mean height. Alright, now let's move on to part D. It says, what was the height of the tide at 2 a.m.? Okay, so 2 a.m. is 2 hours after midnight, so it's t equals 2. So we're going to do y equals 5 sine pi over 6 times 2. That will be 5 sine pi over 3. And sine pi over 3, it's in the first quadrant. Everything is positive in the first quadrant. Draw your cast diagram. So sine pi over 3 is root 3 over 2. The answer would be 5 root 3 over 2. Okay, 3 meters. Now we don't need to consider the solution in our second cycle because that will be 2 p.m. and we're only looking at 2 a.m. Okay. Now let's have a look at part E. So it says, what was the height of the tide at 2 p.m.? So 2 p.m. is 14 hours after midnight. So we solve H14. And that is 5 sine pi over 6t. So we substitute 14 into t. 5 sine 14t over 6. That's 5 sine 7 pi on 3, which is equal to 5 sine pi on 3, because 6 pi over 3 is a full rotation of the unit circle, so we end up where we were. That's why we could just subtract this from that to get pi over 3. And we know that sine pi over 3 is root 3 over 2, so we times 5 to that, which is 5 root 3 over 2 meters. That will be our answer. Now, last part, we have F, part F. It says, a boat can only cross the harbour bar when the tide is at least 2.5 meters above mean sea level. When could the boat cross the harbour bar on this day? Okay, key informations. It says when the tide is at least 2.5 meters above mean sea level. That means it can be 2.5 or greater. And our mean sea level is 0, because there was no vertical translations to our graph. So we just solve for h equals t first. Now that's our minimum value. H equals 2.5. Alright, let's do it. So that's 5 sine pi on 6 times 2.5. That's 5 sine. Oh, wait. No, sorry, that's not right. We need to solve for t when h is 2.5. So we do 2.5 equals 5 sine pi on 6t. Divide both sides by 5. Becomes half equals sine pi on 6t. Now we know that sine pi on 6 is half. So that pi on 6 t has to equal pi on 6. And now there'll be two answers in one full rotation. So draw the cast diagram. Sine is positive in the first and the second quadrant. And if the angle in the first quadrant is theta, then the angle in the second quadrant is pi minus theta. So our second answer is pi minus theta. Okay, so pi minus pi over 6. Okay, now the period, this graph was 12. And we're trying to find when the boat can cross the harbour bar on this day, which means 24 hours. There'll be 2 cycles, so we need to add another rotation to our answers. So this will be our answer. So it's saying pi on 6t is equal to pi on 6, 5 pi on 6, 13 pi on 6, and 17 pi on 6. which is equal to 1, 5, 13, and 17. Now, that's not our final answer, because we need to, let's draw a graph. So it would look something like this. Okay. That's one cycle, and that's the second cycle. So it says 2.5 meters above mean sea level. So let's say this is 2.5. And it says the boat can cross the harbour bar when the tide is at least 2.5 meters above mean sea level. So that includes all the y values that are greater than 2.5. So it includes all this area, where that is 1, that is 5, and that is 13, and that is 17. So our final answer is actually between 1 and 5 a.m. or between 1 and 5 p.m. Okay. Now let's have a look at question 2. Question 2 says a particle moves on a straight line OX and its distance x meters from O at time t seconds is given by x equals 3 plus 2 sine 3t. It says find its greatest distance from O. Okay, so we're trying to find the maximum of this function. So the maximum is midline plus amplitude. This graph, our midline is 3 because 3 is being added to the graph. Our amplitude is 2. So our greatest distance from O is 3 plus 2, which is 5 meters. Part B, find its least distance from O. So that's midline minus amplitude. 3 minus 2 equals 1. So it's a meter. Part C says find the times at which it is 5 meters from O for t is between 0 and 5. Okay, so we're given the distance, x equals 5. We just need to solve for t. So it will be 5 equals 3 plus 2 sine 3t. It's 2 equals 2 sine 3t. 1 equals sine 3t. Now, let's draw a quick unit circle here. Sine is only positive when it's 90 degrees. So that's 1. If it's there, then it's 0, right? Because we're looking at the y-coordinate. That's 1, and that's negative 1. That's 0, and that's 0. So we know that sine pi on 2, which is 90 degrees, is equal to 1. So 3t is equal to pi on 2. Now we need to have a look at the period of the graph. The period of this graph is 2 pi on 3, which is approximately 2.09. So in the domain, that's telling us there will be two and a half cycles. 2.5 cycles of the graph. Now that's important because it tells us how many times we have to add 2 pi to our answer. Since that's 2.5 cycles, we'll add 2 pi 2 times to pi on 2. Plus 2 pi, pi on 2 plus 4 pi. That will be pi on 2, 5 pi on 2, 9 pi on 2. So t is equal to pi on 6, 5 pi on 6, then 9 pi on 6, which is 3 pi on 2. That will be our answer for t is between 0 and 5. Okay, let's move on to part D. Part D says, find the times at which it is 3 meters from O for t is between 0 and 3. So when x equals 3, let's do it. 3 equals 3 plus 2 sine 3t. Cancels out, and 0 equals 2 sine 3t. Sine 3t is 0. Okay, unit circle again. Sine is 0 when it's 0 degrees. That's 180 degrees. So it's saying 3t is equal to 0 or pi. And then we need to add 2 pi onto these answers to find all the possible x values within the domain 0, 3. Okay, so let's add 2 pi to 0, which is 2 pi, 3 pi, because pi plus 2 pi is 3 pi, and that will go on forever. But now let's work out the value for t. 0, that's pi on 3, it's 2 pi on 3, that's 3 pi on 3. Now 3 pi on 3 is pi, and pi is greater than 3. So that is not included in our answer. So our final answer is t equals 0 pi on 3 or 2 pi on 3. Okay? Alright, so that's question 2 finished. Let's have a look at question 3. Question 5. Level 3. It says the temperature T degrees Celsius in a town over a day is modeled by the function with rule T equals 17 minus 8 cos pi T over 12, where T is the time in hours after midnight. What is the temperature at midnight? Okay, so saying what is the temperature when T equals 0? Because T is T is hours after midnight, and to find the time and to find the temperature at midnight, we substitute T equals 0. So T equals 17 minus 8 cos 0. Cos 0 is 1. So T equals 17 minus 8, which is 9 degrees. Part A finished. Part B. What are the maximum and minimum temperatures reached? The maximum, before, was the midline plus amplitude. So it's 17 plus 8, it's 25. The min is the midline minus amplitude. So it's 17 minus 8, which is 9 meters, or degrees Celsius. Degrees Celsius. Okay, now let's do part C. At what times of the day, to the nearest minute, are temperatures warmer than 20 degrees? Alright, so our temperatures has to be at least 20 degrees. So let's just solve for big T equals 20 first. Saying 20 equals 17 minus 8 cos pi T on 12. That's 3 equals negative 8 cos pi T on 12. It's just saying that cos pi T on 12 equals negative 3 on 8. And now what this negative is telling us is that the answers are in the second or the third quadrant, because cos is negative in the second and the third quadrant. Okay, so that means pi T on 12 is equal to cos inverse of 3, 8. Oh wait, though, so it's pi T over 12 is equal to pi minus cos inverse cos of 3 over 8, and pi plus cos inverse of 3 over 8. We got rid of the negative here. I got rid of this negative because that's not useful to us. It just tells us which quadrant it's in. And so by doing the inverse cos of 3 over 8, we calculated the acute angle here. And using that acute angle, we could find this angle and this angle. by doing pi minus t, which calculates this, by doing pi plus t, which calculates this. Next step is we need to calculate how many cycles or periods this graph has. So the period is 2 pi over pi over 12, which is 24. So since we're finding what times of the day, which is 24 hours, there's only one cycle that we have to find. So these two are our answers. If we put that in our calculator, you'll get 1.955 and 4.328, and that's pi over 12t. So t is equal to 7.47 and 16.53. So to answer our question, so that's in hours. So at times 7.47 hours and 16.53 hours, the temperatures are warmer than 20 degrees. And to convert that to the nearest minute, 7.47 becomes 7 plus 60 times 0.47, which is 7 plus 60 times 7. Oh no, 7 point to the 7th hour and 28 minutes. So that's equal to 28, so 7:28. And 16.53 becomes 60 times 53. Put a number behind decimal place, which is 31. So that's 1631. So we can say that between 7:28 a.m. and 4:31 p.m. the temperatures are warmer than 20 degrees. Because our cos graph would look somewhat like this. Let's say that's 20 degrees. So that is 7:28 and that is 4:31. Okay, now let's move on to part D, which is sketching a graph. Alright, part D. Let's sketch t equals 17 minus 8 cos pi t on 12. Draw your x-axis, y-axis. First you wanna... Alright, let's move the x-axis down a little bit. Let's label the midline first. Let's say that's 17. Let's say that's 25. That's 9. So these are the max and mins, because the midline is 17 and the amplitude is 8. Okay. So now we calculate the period. Period is 2 pi on 2, 12, which is 24. So that there is around 24. That's the approximately halfway line. Normally a cos graph would look something like this. But since we have a negative multiplied to the 8, that is flipped by against the x-axis, so it becomes something like this. Okay. Now that the maximum would reach there, it will start on the 9 and it will finish on the 24. So our cos graph would look something like this, and that will be our graph, because it says sketch the graph for the temperatures over a day. 24 hours is equal to 1 day. Now here's question 4. It's the last question. Question 4 says the depth dt meters of water at the entrance to a harbor at t hours after midnight on a particular day is given by dt equals 10 plus 3 sine pi t over 6, where t is between 0 and 24. So sketch the graph of dt for t is between 0 and 24. Sketch. Midline. Midline is 10. Just add it to the graph. Okay, amplitude is 3. The period is 2 pi on 6, which is 12. Okay, and we need to, and t is between 0 to 24, reading that there are 2 cycles. This graph. Let's draw it. X-axis, y-axis, midline is 10, so that's the x-axis. 0, so that's 10. So that's the amplitude, 3, 7, and 13. This is not very neat, but oh well. Now the period is 12, so let's say that's 12. It's 24. That's not right. So that's 24. And so that would be halfway between 12 and 24, and that would be halfway between 0 and 12. So our sine graph would start here. It would go up to here. Then it will go back here. No, that's not right. So our sine graph will start here, go up, go down 1, go back up, go down here, and go back to where it started. So let's draw it. Goes something like this. So that will be our sine graph, and that's part A. Now part B says find the values of t for which dt is greater than 8.5. So dt is the depth in meters. So let's substitute d equals 8.5. So 8.5 equals 10 plus 3 sine pi t on 6. So that's 8.5 on 10 equals minus 1.5 on 3 sine pi t on 6. So that's negative half equals sine pi t on 6. So we know, using the cast diagram, sine is negative in the third and fourth quadrant. So our solution would look something like this: pi plus theta and 2 pi minus theta. To find theta, we know that sine pi on 6 is equal to half, so theta is pi on 6. So our solution in the third quadrant would be pi on 6 plus pi, and the solution in the fourth quadrant would be pi on 6, 2 pi minus pi on 6. And now that's one rotation of the unit circle. So there are 2 cycles in this graph, so we need to add 2 pi to each of these solutions. It'll be pi over 6 plus 3 pi, and 4 pi minus pi on 6. Okay, so it's saying pi t on 6 is equal to 7 pi on 6, 11 pi on 6, 19 pi on 6, and 23 pi on 6. So t is equal to 7, 11, 19, and 23. Now if you read the question carefully, it says find the values of t for which dt is equal or greater than 8.5. So let's use our graph here. So let's say this line here is 8.5. So that's 8.5. So this point here is 7. So this point is 7. This point is 11. This point is 19, and this point is 23. Now we want to find all the possible x values where y is greater than 8.5. So that's these parts here. the graph. They're all higher than the blue line. So our domains would be between 0 and 7, union, or between 11 and 19, and between 23 and 24. So that will be our answers. So if I write that out fully, t would equal between 0 and 7, union between 11 and 19, union between 23 and 24. Done. Now let's move on to part C. Part C says boats which need a depth of W meters are permitted to enter the harbour only if the depth of the water at the entrance is at least W meters for a continuous period of 1 hour. Find, correct to one decimal place, the largest value of W which satisfies this condition. Okay, now it seems complicated, but it's really not. Now, let's draw a graph. Let's draw a bigger graph. That's around 12. Now that's, I'd say that's around 10. Actually, we'll only draw one period. So 12 up to here, and then that's 10. That will be 7. That will be 7. 13. It's not to scale. Okay, that's the midline, 6, and that will be 3, and that will be 9. Okay, so sine graph starts on 10, comes back to 10 on 6, and goes back to 10 on 12. It goes up, it goes down. So it would look something like this. And that's one period. Okay, so we're looking at this part here. We're only going to look at this part because we want to find the greatest value of W. So this part is the maximum of the graph, 13. And let me read you the question again. It says boats which need a depth of W meters are permitted to enter the harbour only if the depth of the water at the entrance is at least W meters for a continuous period of 1 hour. It says for a continuous period of 1 hour. Okay, so find, correct to one decimal place, the largest value of W which satisfies this condition. Now, to solve this, we need to look at the behavior of sine graphs. Instead of a sine graph that looks like this. This part, if I draw a line here, this side and this side is symmetrical. It doesn't look symmetrical. I'll draw it again. So it looks somewhat like this. And this side is symmetrical. So this is 3. And if I draw a line, a horizontal line, maybe let's say that's y equals 4, then this point and this point would be, so that point would be 3 plus something, and that point would be 3 minus something, and the squares are equal to each other. Now, using that, we can solve this problem. So we want to get the maximum point, which is 13, because we want to find the maximum value of W, and that needs to be sustained for a continuous period of 1 hour. So if that's 3, let's say that coordinate is 3, 13, then we move up 0.5 and we move down 0.5, and these y coordinates will be equal. Now the reason we move up 0.5 is because 0.5 plus 0.5 is an hour, and the question says that the depth needs to be maintained for a continuous period of 1 hour. So this and that's 2.5 and that's 3.5. So our required period of time is 2.5, between 2.5 and 3.5. And so we can say that the greatest value of W occurs for t equals 2.5. We can use 3.5, but we'll use the smaller value. So let's get our equation. equation and substitute t equals 2.5. I'm saying w equals 10 plus 3 sine 2.5 pi on 6. Okay. Now put that into our calculators. 10 plus 3 sine 2.5 pi on 6. That will be equal to approximately 12.9. So W is 12.9 meters. And that will be the maximum value of W.